In 1818, Mary Shelley published a very famous story about an artificial being with intelligence called Frankenstein. Our idea of artificial intelligence, or AI, has evolved a fair bit since then. But it's fair to say that fictional storytelling is still a big part of the AI we see in media. So what is AI, and how much of it is already in the technology we use every day, in our personal lives and in industrial processes? Let's take a look. Artificial intelligence, or AI, consists of several parts, and the nature of this intelligence, it's changed a fair bit over time. Let's take a look at 7 capabilities that will help you get a better picture of what AI is. As we go through them, I'll show you how each of these capabilities is being used in the world around you. And you'll notice that these capabilities build on each other as we go through them. Let's start with the first one. The first one is reasoning or problem solving. And this kind of came to be in the 1980s and maybe early 90s. And a good example of this would be in industry, like a vibration sensor on a motor. So if you're a plant worker and you walk through the same industrial plant every day and you hear the noises around you, and all of a sudden one day a noise is different, you'll know you need to pay attention to that. Well, this is exactly the same thing vibration sensors do. So when a vibration sensor records the noise or records the vibrations, it's going to have a very consistent pattern almost all the time. And then if that pattern changes, then we know something needs attention. This is that kind of reason or problem solving basis. If this happens, then you need to do this. Another example of this is in the 80s. This was the only tool they had, so they tried to apply it to weather forecasting, where if these certain conditions were met, then this is probably what the forecast would be. Some even tried to apply it to the stock market to say, if these signals happen in the stock market, then this will probably happen next. I don't know that it works so well for weather forecasting or stock markets, but it works really well for something like a vibration sensor where the pattern is a lot more predictable. The second kind of builds on that, and it's around knowledge representation. This is kind of what started to happen in the mid-1990s with Yahoo and Google, where there was so much knowledge being stored on the internet that somehow they needed to make sense of it. The search engines that were looking for this information needed to structure it and needed to be able to find information when someone asked for it. And so there was a whole data science that was built around this, and a knowledge tree wasn't quite comprehensive enough. So they needed to represent knowledge in other ways in the data so that they could find it quickly. A good way that we use this today, even within Cisco, is for network troubleshooting, right? There are so many factors at play that just a simple decision tree doesn't really get you where you need to go. There are other ways of dealing with this knowledge capture that we have that associates certain kinds of combinations with certain outcomes and allows you to predict. A third aspect of artificial intelligence is called natural language processing. And this kind of builds on that knowledge representation in terms of the actual interface to that knowledge. And probably the most famous example of this is Siri on your iPhone, where you can say, "Hey Siri," and then ask it a question, and it knows what you're thinking. It will infer all kinds of meanings and then use that to actually go search for something in that knowledge base. So that natural language processing has become really important in things like call centers, if you're phoning into a help desk, so that you can actually talk to the computer at the other end and it can figure out what it is you're looking for before they connect you with an agent. The fourth aspect of artificial intelligence is machine learning. And this is probably one of the most important ones when it comes to energy or mining. And we've seen a lot of modeling that has come out of machine learning, and that's really what machine learning is a lot about, is classifying data, and also maybe if it's continuous data and it's not discrete in nature. If it's discrete data, then you put it into groups. So this data point goes in this group, this data point goes in this group, and you're able to categorize data based on certain characteristics. That's called classification. And machines can learn to classify. If you give a machine a whole data set that's been pre-classified, it will learn how that classification process works. And then if you give it new data, it will be able to classify that data for you. If you have continuous data, like maybe temperature levels or sound levels, these are not discrete values, right? So they actually have a continuous range of values that could occur. And in those cases, it's helpful to use sampling points to build a regression model. And so that type of machine learning is called regression. And there's all kinds of complex regression models that you can use to predict behavior based on what kind of model comes out of a whole set of data points. And then you can predict the outcome of new data points based on that model. So that's machine learning. And that's how a lot of the predictive maintenance algorithms are built, and a number of other predictive models or decision-making models today in more modern operation systems. The fifth one, and now we're getting into more of the forward-looking artificial intelligence, is around motion and manipulation. There's been an awful lot of work done on this in the last few years. And the whole field of study around teleremote robotics or autonomous robots, and this isn't just sort of humanoid robots, but even self-driving machines or teleremote machines. This is used a lot in mining. There's a whole science built around that and the machine learning and artificial intelligence that comes along with predicting and controlling in certain ways based on what it sees in its visual sensors and other sensors, LiDAR sensors and sound sensors and all kinds of things. And so being able to take in the whole environment around you and make decisions based on that as to where to move to and how to grab things or move things around from a manipulation perspective becomes really, really important. This is a huge saver in terms of efficiency and productivity when you can take the human element either out of a situation or multiply the effort of human involvement. In the case of teleremote, where say in dozing within a mining operation, you might have one person operating 4 or 5 dozers, and they'll give instructions to one dozer and it will go off and carry out those instructions. And while it's doing that, you know that operator can actually set up another dozer to take on their instructions. So that's the whole artificial intelligence around motion and manipulation. What are we up to now? The sixth one is social intelligence. And this is used a lot in the social media world to analyze sentiment of language and predict feelings and emotions of different authors or different people by the way that they behave and the way that they speak, and to be able to do social classification or social prediction based on the information that you're gathering in. This has huge implications for responding appropriately to people that machines are interacting with. And this is still not quite there, but it's made huge improvements over the last years, and we're going to see a lot more investment in that going on. Now, the seventh one, it's kind of, this is the last one in my scale, and there's probably others that I could dive into that kind of fall in between some of the ones I've mentioned. But the kind of eventual goal for AI is general intelligence. And really, general intelligence is a little bit of a hypothetical idea. It's really around building a cognitive system, an artificial brain, if you will. A lot of this is being used in the medical field around, say, simulating child development and understanding how the thought process develops from a baby through to an adult. Because if you can simulate that process, then you can understand the learning idea and how to become more autonomous as a machine, maybe in a similar way to the way humans become more autonomous as they grow older. That ultimately kind of leads you to what a lot of sci-fi movies have depicted as a robot apocalypse, right? And maybe that's taking it a little bit too far, but ultimately that's where the general intelligence idea takes you to, is where machines start to become more intelligent and more capable of processing environments and developing technology for themselves than, say, the humans are. Right? And so they end up taking over this robot apocalypse thing. I don't think we're going to be there yet in a little while, but ultimately that's the whole continuum, from the simple decision tree of the 1980s all the way through to this idea of general intelligence, where machines can start to think for themselves and develop for themselves. And we've learned to harness a lot of these steps along the way very effectively. The robot apocalypse idea is definitely predicted by some. But what's encouraging is that the pessimists around us have predicted many apocalypse events. And as a society, we've always found ways to mitigate these risks. So I'm actually hopeful. If you found this video interesting, click like and subscribe, and then get on with the next video. Take care.